right, let's have a look at finding the vector that will give the midpoint of a line, and then also any point that divides that line into a certain ratio. I have pre-drawn the vectors to try and save a bit of time. It's important that you don't try and memorize a formula for this. Rather, learn to nut it out using vectors because it will make your life a lot easier in the long run. Okay, the first one they're looking for is the midpoint of AB. So the midpoint will be someplace in the middle of this line. Let's just mark it over there. That looks about right. And so what we're looking for is the vector OM. All right. So what we've been given is that, oops, I want a blue pen. OA, our vector OA, we can write that in component form. So 2i plus j, and our vector OB is going to be 7i minus 4j. All right, now we're looking for vector OM. So in order to find OM, okay, I need to go from O to A and then A to M. So OA plus AM. Now that seems okay. How can we relate this AM to our AB? Well, we know that AM is half as long as AB. So that's OA plus half of AB. Now what's nice about being able to do that is that we already know that being able to find from A to B is just going to be negative OA plus OB. So that means I've got my OA over there plus a half times negative OA plus OB, because that's giving me my AB. All right, and now I can simplify that, and I've got OA minus half OA just leaves me with half OA plus half OB. And once we've actually nutted that part out, all we need to do is substitute in our vectors OA and OB. So we've got half times 2i plus j plus a half times 7i minus 4j, and might be easier to write it all over 2 so that we can easily add and subtract. So maybe write that as 2i plus j plus 7i minus 4j all over 2, and that gives me 9i minus 3j over 2, and we usually separate them, so 9 over 2j minus 3i minus 3 over 2j. So our vector that describes the midpoint of AB is 9 over 2i minus 3 over 2j. And you can check yourself, because if you have a look, this looks like it's approximately the midpoint over there. And if I go here, 1, 2, 3, that looks like it's about 4.5 and minus 1.5. And that was just my guess of where it would be. So it kind of makes a bit of sense. All right. For B, the point C that divides AB in the ratio of 3 to 2. All right. Now, the 3 and the 2, the order is important. It divides AB in that ratio. So from A to C to B. So my A to C is going to be the bigger number, the 3, or the first number. And my smaller number will be the 2. So point C, I've got a ratio of 3 to 2, where that one is the 3 and that one is the 2. All right, so let's have a look. Let's nut that out again using our vectors. So this time we're looking for OC, and to find OC, that needs an arrow. To find OC, we need to go OA plus AC. And now we need to relate this AC to our AB, which we are able to find. So that means OA plus, now let's have a look. Point C is 3/5 of the way to point B. So my total number of divisions is 3 plus 2, which is 5. But 3/5 of the way is where I'm going to find C. So 3/5 of AB. And I know that to find AB, I'm going to go is negative OA plus OB. So I've still got OA plus 3/5 negative OA plus OB. And as soon as I'm getting into the OA plus OB, I've got all the information I need. Okay, so now I have OA minus 3/5 OA. Let's write that out. Minus 3/5 OA plus 3/5 OB, and 1 or 5 over 5 minus 3 over 5 OA gives me 2/5 OA plus 3/5 OB. So once we've got to this point where we now know that OC is 2/5 of OA plus 3/5 of OB, we can substitute those values in. I'm going to write it all over 5. So 4i plus 2j plus 21i minus 12j all over 5. And that will give me 25i minus 10j over 5. And I can simplify that down to 5i minus 2j.